In our fifth objective of practice test B, we're asked to calculate the enthalpy change during a dissolving process in our thermochemical data. Some of the notes that might help us in tomorrow's test of objective 5, we are being asked to take a solid and dissolve it into the water. Mental note, there is a solid being placed into water. The water will not react. It will be on the arrow showing that it's simply there to be the solvent, the solution medium. Over here, we are going to produce ions that are positive in aqueous solution and an ion that is negative in aqueous solution. Solids, when they dissolve, will dissociate. They'll break apart and form positive and negative ions. Reading through our first question, it says, solid magnesium hydroxide. When I think about magnesium carrying its +2, hydroxide with its -1, when I write the solid reactant MgOH taken twice. Magnesium hydroxide being dissolved into water shows the water on top of the arrow. It reads forming aqueous magnesium ions and hydroxide ions. On the left side in the solid form, when they're hooked together, we use those charges to write our solid compound by crisscrossing. When we break those ions apart, we show those charges up high as a superscript, and the adjective becomes aqueous. Magnesium ion in its aqueous form, and the negative ion is hydroxide. OH carries a -1. Notice that when we balance the charges on the right-hand side, we had a subscript of 2. To keep the equation balanced, we will now double the number of hydroxide ions coming out. MgOH taken twice as a solid, when dissolved in water, forms a magnesium ion and 2 units of hydroxide ion. We'll need to turn this balanced equation into a thermochemical equation. 750 kJs per mole of heat was released. In the releasing of energy, we know that to be exothermic. We'll show that as a negative sign. Negative 750 kilojoules of heat released. Now that we have written our thermochemical equation, we'll do a little stoichiometry problem related to the very equation we wrote. In our letter B, how much heat in kilojoules is released when 50 grams of magnesium hydroxide is dissolved in water? Given our 50 grams of magnesium hydroxide, MgOH taken twice, this is our given quantity. In our given quantity, we want to go to kJs of heat. A step 1, step 2 on our stoichiometry roadmap where we want to get to kilojoules given the mass of our reactant, magnesium hydroxide. We'll need a molar mass of magnesium hydroxide in that first conversion, Mg, who has a molar mass of 24.3, plus 16 times 2 on the oxygen, and 2 more for the hydrogen. I found 58.3 grams of MgOH taken twice, set under the 1 mole of magnesium hydroxide. This has allowed us to cancel the gram unit and moved us into the mole. We want over given stoichiometric ratio. We know that negative 750 kJs of heat are released for every 1 mole of the solid magnesium hydroxide that has dissolved. Let me hit for us 50 divided by our molar mass times negative 750, and I'm showing an answer of negative 643.2 kilojoules of heat.